Do you own a multimeter? If not, you should, because multimeters are an essential tool for electronics diagnostics and repair. A multimeter is actually multiple tools crammed into one, a true Swiss Army knife of electrical forensics. It can help you figure out where electricity is flowing. It tests for AC/DC voltage and current, continuity, resistance, capacitance, diodes, and non-contact voltage. You can use it to check the voltage in an outlet, test old batteries in a drawer, and figure out exactly what part of a gadget has gone bad. Today I'm going to show you how to use some of the basic functions of the iFixit digital multimeter. Let's start out by getting an overview of the device itself. Out of the box you'll have the multimeter and 2 test probes. The multimeter is rated up to 500 volts and 10 amps. This means it'll be good to test most things in your house. But if you're working on the electrical systems in a commercial building, or maybe you're troubleshooting your EV charger at home, you might want a heavier duty multimeter for that job. It's very important to understand the limits of the gear you're working with to avoid accidental injury to yourself or accidental damage to your equipment. The screen is where our test readings will show. This multimeter has a simple 4-digit display with a backlight for working in dark environments. In the center is the selector dial, and all the way around it are the various test modes we can select. Not all multimeters will have the same test modes, but most will have the basic functions you can see on this model. Attach the 2 probes. The black probe will always connect to the terminal marked negative, ground, or COM, which is short for common as in common ground. The red probe is connected to one of 2 terminals on the multimeter, and which terminal you use depends on the kind of test you're carrying out. The positive terminal on the left can accommodate currents of up to 10 amps, which can be hazardous. As a beginner, you shouldn't have any reason to touch that terminal, and its use is outside the scope of this video. I'll use the terminal on the right instead, which is marked with the symbols for voltage, resistance, microamps, and milliamps. This terminal is fused to 600 milliamps, which means any current above that will be stopped before it can damage your multimeter. So let's learn how to use the most common and useful measurement tools on this multimeter. Starting from the far left, the multimeter is set in the off position and powered down. The next setting powers the device on and sets it to NCV, which stands for non-contact voltage for sensing mains AC voltage. So we're not going to need our probes for this one, because as the name suggests, this is going to be a non-contact test. The NCV sensor is the nub at the top of the multimeter. Simply touch this to a wire. If it has AC running through it, it'll beep. The next setting on the multimeter is live, which is used to check for AC voltage in live wires using a single probe. For this test, we'll need to connect one of our probes to the terminal on the right, also labeled live. Unlike the NCV measurement, the live test allows us to check for voltage in a single wire within a larger clump of wires. Bear in mind it's always prudent to confirm test results by other means. Use the NCV function in conjunction with the live test mode to confirm that a wire is safe to handle whenever possible. Both these tests are great ways to see if a light switch or a wall socket are energized. You can also use it to see if there's a broken wire inside insulation, or to see which wires inside your junction box are hot. The next setting puts the multimeter in voltmeter mode, indicated by the white V symbol, meaning we can measure the voltage potential between 2 points. The solid and dashed white lines above the V indicate that we're measuring DC voltage as opposed to AC voltage. DC mode is the default setting on this multimeter. To take voltage measurements in DC mode, place your probes on 2 points of interest. In this example, I'm measuring the positive and negative terminals of a 1.5 volt AA battery. This one's showing about 1.3 volts, which means it might be good to keep an eye out as it's starting to run low. Looking back at the multimeter dial, notice the wavy blue line above the white V and solid white line. That wave symbol denotes AC or alternating current. The blue coloring signifies that this is not the default measurement setting for this multimeter and can be accessed through the alternate function button, which is this one here. Notice the DC symbol changes to AC on the multimeter screen. Be very careful when conducting tests on AC main supply, like your wall plug. Make sure your hands are dry, that your area that you're working in is clean and free of any potential hazards like liquids that may be knocked over or any other conductive materials. For most people, the likely use case for AC measurements would be to test a wall socket, an extension cord, or a household appliance that runs on AC. I'm testing an extension cord here, and to do that I'm placing a probe in each terminal of the extension cord, and if you live in North America you'll see a reading of around 120 volts. Because this is AC, the polarity of the probes doesn't matter. The next setting on the multimeter dial is diode mode, denoted by the arrow symbol and the straight vertical line, and continuity mode, which is denoted by a single dot with waves emanating from it representing a sound wave. Diodes are components that only allow current to flow in one direction. To test the diode, place the red probe against the long leg and the black probe against the short leg. If done correctly, the diode will light up and you'll see a voltage reading on the multimeter. The LED won't light up if I reverse the probes, because the diode only allows current to flow in one direction. Diode mode also allows for measuring voltage drops between 2 points on a circuit board, among other things. It's a critical but advanced method for troubleshooting board level faults. If you'd like to learn more about diode mode, voltage drops, and other advanced repair techniques, consider signing up for our 2-week course out in Tennessee, led by repair professionals like Jessa from The Art of Repair. I'll leave a link to the sign up page in the description below. On this model, diode mode also places the multimeter into continuity mode. Continuity mode is how we test for electrical connections between 2 points on a circuit. It's useful for finding short circuits where a connection between 2 points shouldn't exist but does. Or it can help us with the reverse to find a broken connection between 2 points that should be electrically connected. Here's an example. This IC is connected to a button that the user presses, which generates a sound. I should be able to verify that there's a signal path between the button and the IC pin. The beep from the multimeter signals a good connection, which is what we want. Say if your screwdriver were to slip while you're working on a PCB and it cuts or gouges through that trace, you would lose connection between the button and that pin on the IC. This is an example of where we can use continuity mode to check that connection and potentially isolate where the fault is. The last setting we're going to look at today is the one marked by the ohm symbol, which represents resistance. The white ohm symbol means that the multimeter will check for resistance by default. Simply place a probe on each end of the resistor being tested to get a reading. Resistors don't have a negative or positive terminal, so I'll get the same reading regardless of how I arrange my probes. On the multimeter, the alternate function at this dial position is capacitance mode. Once again, we can access that alternate function by pressing the blue button. Word of warning, capacitors can hold a significant amount of charge. Make sure any component you're testing is powered down and fully discharged. To take a measurement, attach a probe, polarity doesn't matter, to each leg of the capacitor and read the result. The reading should match the markings on the capacitor. Multimeters are easy devices to maintain. There's only 2 sets of replaceable components in here, the batteries and a couple of fuses. To access the battery compartment, lift the kickstand and unscrew the single Phillips screw on the back. The plastic cover should come away, revealing the batteries. To access the 2 replaceable fuses, first I'll need to remove the outer cover. That reveals 4 screws on each corner of the backplate. After removing the backplate, replacing the 600 mA fuse is a tool-free process. Just take out the bad fuse and replace it with a good one with the same ratings. That's a 600 mA 600 volt fast flow fuse. Reassemble the multimeter and you should be good to go. If you're stuck trying to figure out how to use the multimeter or need a little help getting started with soldering, be sure to check out our guides on iFixit.com, which I'll link below. Happy fixing!